Full vector control, flux vector control, closed loop vector control all refer to the same control method. It is a drive control method that uses an encoder to allow the drive to monitor the motor for the most precise control available in AC drives. Typical modern drives have two velocity control modes, Volts-Hertz and vector or flux control. Volts-Hertz, or volts frequency, simply uses an internal curve like this to send a specific voltage and frequency to the drive based on the speed command. Often these modern drives can also be programmed to apply torque and voltage boost based on speed. This mode is often used for variable torque applications like fans and pumps. When constant torque is needed, vector or flux mode is more appropriate. On many drives, vector control is sensorless, meaning that the drive has no physical feedback device to indicate the motor speed. In this mode, the drive controls the motor speed based on mathematical models involving the VFD voltage and frequency output and the amperage measurement of each phase coming back from the motor. With the advanced processors used in VFDs today, this provides very good speed control acceptable for most applications. However, sensorless vector or Volts-Hertz modes are not well suited for accurate speed control and torque at lower speeds, which brings us to closed-loop control. VFDs with full closed-loop vector or flux control add one additional input to the mathematical model, the physical position of the motor shaft measured by an encoder. This allows the model to precisely adjust to any errors between the commanded speed or torque and the actual speed or torque. This model provides full torque and excellent speed control, especially at low speeds. Typically, precise speed control of 1/2 Hz or less is possible. It's difficult to simulate this without a system designed to take advantage of it, but hopefully you can see here that the motor turns freely at 0 speed when in sensorless vector control. But here you can see there is significantly more resistance, and the drive is attempting to correct the external forces while in full vector control. And yes, I can still turn it, since this is only a 1/2 horsepower motor, so it has limited torque. This mode is often used for crane applications, where full torque at 0 speed is required to hold the load in place when the brake is released. Winder tension web control applications, where speed and torque vary greatly depending on the changing roll diameter, and lifts or elevators, when load control and safety are paramount. Please see this video for full vector operation on a GS30 drive. Find drives for your applications here, and please subscribe to be notified of the latest products and solutions.